Good morning, ladies and gentlemen. Thank you very much for attending this webinar on RockMa's real-time monitoring system for optimizing drilling and blasting. This, I think, is a very exciting technology and one which has tremendous potential for South Africa. My name is Phil Piper from Groundwork Consulting in South Africa, and we've been RockMa Sweden's local partners for this technology for the past 10 years. During the past 20 years, RockMa Sweden has sold hundreds of their systems for surface and underground mining, and especially for tunneling applications across Scandinavia, as well as in Europe, Russia, the Middle East, and of course, South Africa. In South Africa, more than 50 systems are in use, including on almost all the drill rigs at Sishen Iron Ore Mine in the Northern Cape, and Anglo American's massive Mogalakwena Platinum Mine, which is in Limpopo. Although the RockMa system for drill rigs provides all the normal features expected, such as automated blast hole location, drill rig and operator performance, RockMa's speciality is generating accurate information for rock hardness and fracturing in real time. This information then leads to a wide range of benefits, from blast optimization or waste boundaries to determining support requirements. And this will be the main focus of Kari's presentation this morning. Kari is Executive Director of RockMa. He is a Swedish mining engineer by training, with many years of operational and research experience in his local mining industry before founding RockMa in 1999. When he's unable to spend time at his log cabin well inside the Arctic Circle, his passion is optimizing mining processes using the highly accurate and reliable data generated by RockMa systems. Also in line today from Sweden is Kari's colleague and co-director, Patrick Martinsson. Just a couple of things in terms of housekeeping. We would be delighted to receive your questions, but if I can ask that you please enter them by clicking on the Q&A bar in the bottom right. And then at any stage you can do that during the presentation, but we'll only answer questions at the end of the presentation. And please don't use the chat function for your questions. And there's also no hand raising required. And if you could avoid unmuting yourself. And with that, I would like to hand over for the presentation to you, Kari.
Thank you very much, Phil. So, hope you see my screen. So I will actually start immediately because we need our time. I will start with telling that RockMa is a supplier of software and hardware used for management and rock analysis system for the mining, exploration, and civil engineering market. So we are live monitoring of the whole drill process for all type of drilling, such as rotary drilling, percussion drilling, RC drilling, core drilling, or type of rock and soil drilling. So what we can offer, first of all, RockMa is the world leading company in analyzing detailed rock properties direct from the drilling process. We have 25 years of experience, mainly from tunneling in Scandinavia. We have hundreds of systems from tunneling, but now also in production. Rock analysis gives the customer tools to develop all waste boundaries, blasting properties, improve your technical models, improve your logical models, groundability information, and it also gives huge improvement in drill quality, high increase of production, and huge improvement in safety. And also other mobile machines can be added to the system. So the different segments that we are working within is tunneling, open pits, bigger and smaller open pits, exploration, both percussion and diamond drilling, and also underground mining. I will focus this presentation of open pit mining, and I will divide it into 6 different points that I will go through. These ones: real-time management, high precision GPS, fleet management, dashboard, drill pattern designer, and the geological part. RockMa can be installed on all brands and models. So whatever units you have on site, you can put RockMa on all of them. And we supply them complete hardware package and software, of course. And there is alternatives. If you already have rigs with some sensor system, we can use that normally. And if you have also already GPS and monitoring system, we normally can use that as well. So we then just supply the software. And we have these in 2 steps. The level 1 is navigation and management. That is the same platform. Then we can build the total full system, including rock analyze model. So it is possible to start with level 8 and then move to level 2 in a later stage, if requires. So we start with the real-time management and monitoring. This is a real-time system, as I told you, and there is alternatives. We have a cloud solution, normally for smaller pits, smaller operations, but we can also have all the databases and all servers installed on site that we have normally on bigger sites. But on site, we have different software. We have softwares on all the drill rigs or other mobile units. We have GPM plus Office, the Office tool, and that's free amount of license. So you can have how many licenses you wish, that's included. And we also connect us to different customer softwares. If you have some specific software that you already use for planning or whatever it is, or other databases. And we also normally pick up information from other databases, for example, geological boundaries or whatever it might be. We use 3G, 4G for Wi-Fi connections to the rigs in the pit. And we pick up all the satellites and correction signal this way. And we use all the different type of satellites, GPS, GLONASS, and other satellites coming up. This is a picture from a graphical tool, the Office tool. So as I told you, it's a real-time system. So you can actually see the rigs, what they are doing, how they are moving around, drilling, leveling, or whatever they do. So you can just choose which part of the mine or what block or rig you like to follow, and you can highlight that and zoom in, zoom out, and rotate and whatever you like. That's another picture just showing that. 3 rigs drilling on the same block, showing the rock properties while drilling. We have a dispatch view where you have a lot of information available that they normally have this one from the control room, and they are sitting 24/7 normally. They can see the performance, who is drilling, what blocks, how many drill holes, and a lot of other information. I can't go through them all here, but it's just an example. This is an example from the operator software. You can see his green drill rig, meaning that he's the one that is showing the screen just now. The green colors is the drill holes that has been drilled, and the color means that they have it's a quality hole. They have fulfilled the quality accuracy. And you can also see a small rig down on the bottom side, it's a contractor rig. So the operator can see all the rigs around, so they can actually see each other and communicate. And the other circles with the triangle is actually the sockets. That's the bottom of the hole drill from the previous bench. It's a potential misfire, and you are not allowed to drill on those positions. So you have a security distance around those. So if you use the RockMa in fully, so you have the drill pattern designer, we automatically, when you design the block, you move away from those sockets. But if you use another system, then it can happen that the socket position comes too close to the drill hole, and then all the warnings comes up, of course, and you just need to move away from that position. This is another example. The darker green is actually the one that you're sitting in just now. So you can see your fellow drill rig in the lighter green. And you can also see another rig down here. It's an arrow showing that you have a pit viper standing 30 meters away. All rigs inside 100 meters from your position will be shown as small arrows, so you can zoom out and you can see them. This is another small feature in the system. It's a planning, actual and plan for the blocks, block planning. Here you can actually see a timeline on the bottom axle and drill holes on the other axle. Now I actually need to move that one. Okay, yeah, I don't see that. And then you put in the starting point, comes automatically, of course, and you have a due date when it should be completed. And the system then keeps track if you are ahead of your planning, or if you are within your planning or behind your plan. And then it will automatically show you with an easy overview. You see all the time, every second, how you are drilling according to your plans. Another example is that one. I don't need to go through those in details. This is actually from a customer comment that they also have increased their production by looking at the head turn time percentage from the production drill rigs. So the actual head turn time, meaning the actual drilling, has improved from below 40% to over 75%. And that gives you more meters, of course. So that is from a customer that sent us this one. The drill management and live drill monitoring. This is also copied from a customer document. Their goal are to drill safety at the correct position to the correct depth, achieving proper hole integrity and proper drill sequence with completing the work on time. Drill management monitoring, block management, drill sequence management, socket management, hole management, advanced time management based on the local mine availability model integrated with SAP, advanced consumable management, meaning that we keep track on bits and rods all the way when it arrives to the site, and we follow it, the whole chain and meters and so on. Communication management, maintenance support, real-time decision making. So this is actually a customer document. That was some words around the real-time management. High precision GPS position navigation. This is then centimeter accuracy for the GPS. And the reason why you want to have it on XY is, of course, that you will have the fragmentation control over that and all the drill meters as well. So that's natural. The vertical control is very important, of course, to have the flat benches. So RockMa is working that way that immediately when starting drilling, from that second, we calculate the depth from the actual position of the bit down to the plan evaluation drill level. And this is how it works all the time. So wherever you are on the top of the bench, it always calculates your drill distance down to the evaluation level. However good plans you have done with scannings and everything, you are never in the correct position. So this is an example from one of the mines, but it's the same in the other mines. If you have an XY coloring within the whole diameter, in this case it's 32 centimeters. So if the position are within the diameter and you drill to the depth within the tolerance of 30 centimeters, then you can classify the hole as a quality hole. When we started in these mines, the actual quality drilling was sometimes as low as 5%. In this case, it was the blue color shows total amount of drill holes. The yellow one is quality holes, and the line is the percentage of the hole, quality holes compared with total holes. So when we started installing, it was around 20% quality drilling. And here you can see that something happens. That was the time when the management in the mine went in and bought in the system totally. So they went 100% efforts to use RockMa in all points. And after that, it has been around 100% quality drilling in the mine. They do that continuously. Floors with improvements clearly visible. If you go down to the mine, you can clearly see the flat floors. And of course, that gets less bulldozer hours and all other vehicles you use in the mine. It's much easier to access all over. You can see that in the picture. Drill sequence also goes with the positioning. You can actually plan the drill sequence in beforehand. So these lines is how they have drilled, and the line before is the plan sequence, how they should drill. So you can see that they have followed the plan and done a good job. So especially if you have many drill rigs on the same block, you can have control over each other and you can do optimized planning. Fleet management. It's not only the drill rigs that we can manage in real time. We can also add other units as trucks, as excavators, for example. This is ongoing projects at the moment in a couple of mines. And also the roadmap. Here is just one example from the software. You can see where they are in the 2D screen, where the machines are standing and what they're doing, and you have the roadmap as well. The roadmap automatically updates in a specific frequency, once a week or once a month or whatever you have put. It reads the mine surveyors databases and it updates the roadmaps automatically. So you can always, if you like to go to a big open pit mine, you can take out the map and find the easiest road to drive down. A lot of other information, of course, as well. For example, pop-up windows that attends if something happens on the rig. Immediately a pop-up window will show both office and rig software, and also other type of communication between each other and a lot of other information that is available all the time. Dashboard. The dashboard is a very, very huge package, but it can be adjusted to the customer exactly what they like to have. This is just some examples that I will show you. For example, production, you can compare plan and actual outcome. You have quality of drill quality, showing your performance, and this you can put your time limit. It can be per day, per week, per month, whatever you choose to put. The contractor rigs, primary production rigs, whatever you like to follow up, and shift A, B, C, D, or whatever you have. Also time distribution, you can follow up what is happening, and also operator scoreboard. In these mines, they have a lot of operators, so they have actually an operator scoreboard. It's a combination of drilling time and quality drilling. You can weight that how you like. I think they have 50-50 in these mines. Shows the top operator, how they are performing. And at least before, they invited the top 3 or 5 of them every second month to dinner and had a small party for them. But for the mine, it's of course very much important to look at the bottom 5-10. You don't see that, of course, in that scoreboard, but you have that information. So you know who you need to train and what you need to train them in. So that's actually a quite important part. You can then go into more details. For example, direct operating time. You can divide it in actual the head turn time, primary production, or whatever you have in your codes. You can go down equipment downtime per rig, and also lost time and so on. And then you can take a further step down and look at the direct operating time. You can see the idle time, the drilling, leveling, moving, whatever they are, if they are performing differently. And this you can then choose per rig, per whatever, per shift, or whatever you like to look at it. Equipment downtime per rig, the most common error downtime, lost time, etc. And you also have trend curves. By clicking on bars, you can see trends, how they are performing. This is just some parts of the dashboard. So the dashboard is a very, very big unit itself. And the drill pattern designer, this is included in the system. It's not needed to be used. You can use whatever system you have, and we can add that information into the system. But we have a module for that, and it's very appreciated where they are using it. So it's very easy to use and it's very powerful. It's integrated drill pattern designer to fasten safety. You can take care of the socket, design drill patterns, identify sample holes. Many mines, they take chip sampling from some holes, not all. Here you can decide exactly what holes you like to sample. That information will follow down to the operator, and we actually have a hooter on the rigs that gives signal for every position where the chip sample need to be taken. And also electronic tracking of approvals to comply with the legal requirements, meaning that some people are responsible for the sample holes, for example, other for the rock boundary, for the ore boundaries. And in the end, someone needs to approve it, a appointed person. And here you can track exactly what persons have done different things in the chain. Integration with other functions and RockMa data to assist with drill pattern designer. As I told, for example, geological information and so on. This is just examples from the drill pattern, but I think the normal comment is that you create a block, a drill pattern in a very short time and very accurate, and then you just dedicate it to the correct drill rig. Detailed rock property information. This is actually where we are coming from. This is where we started the company from, to have the rock property information. And the rock property information we can get from the drill process itself. We don't do any other measurement in the drill holes and so on. We just measure the drill process by looking at the different parameters from the hydraulic system. And this is some of the pressures and flows that we are measuring. So we just measure the rotation speed, feed pressure, rotation pressure, and so on. And then we calculate that. So we can take care of all the influence from the operator, all influence from the drill bit conditions, from the road conditions, from the machine condition. We can take that together and we can eliminate all the parts that do not influenced by the rock type. And then we present the rock mass information. And we can do that online with having the software on board the rig. Normally in tunneling, we don't do that. We do that on the office. So normally they send automatically up the information hole by hole. So the surface persons can follow the drill process. But we can have it in open pit mines, they have it online. Underground, we normally monitor every 2 centimeters. That's a very common interval. And on surface, depending on the diameter, it can vary down from 2 centimeters up to 4 or 5 centimeters, whatever is suitable. And the parameters that we are calculating is hardness. And that's normally uniaxial rock strength with megapascal, meaning that if you have many rigs on site, all the rigs will show you the same information. And also fracture and homogeneity information and water conditions. Water is very common in tunneling to also measure the water. Yeah. And then we can actually use these parameters to combine them to give other parameters. I mean, for example, injection information, blastability information, groundability information, whatever you are looking for. This is the ground parameters that we then start calculating around and can give the customer what they are looking for. This is an example of one open pit mine. This is thousands of drill holes in a vertical profile. You can see a lot of holes along this vertical picture, but you can see the structures very clearly. The blue and the red is ore, and the yellow and green is waste rock in this specific mine. And you can also see the lower picture showing the fractures in all the drill holes, that you have zones with very fractured rock and zones with very solid rock. And already in a typical picture like this, the studies we have done before shows that fractured areas gives much worse blasting properties. And normally when we show mines pictures like these, they can identify quite immediately what areas they had problems with blasting. So by having this type of information, you can make research backwards. You can actually look at the blasting result by looking at the rock properties, calculate the result of the blasting, and go backwards that way and see what properties gave that result. And that way you can start building your blasting properties on that site specific condition, because this varies from site to site and you need to do that exercise on all the different sites. This is another mine showing also hardness variation. So it's a quite big open pit we divided in different sections, and you can clearly see that you have some weak sections crossing the open pit. And if you look at the vertical section, you can see how they are dipping. Another smaller mine in Scandinavia, just showing different hardness and fracture, but also fracture frequency. And fracture frequency is actually something that we prefer people to work with. I don't think they are doing that in so many cases, but that is a much better way to actually see it's the average of fractures per meter per drill hole, whatever you have defined. So you can, in a very easy overview, you can see where you have the more problematic areas. It's much more difficult to see that when you go into single fractures and try to summarize those. It's much easier to see that in the overview. This is an example of production drilling combined with RC drilling. It's a mine when they have the system on both. So you have your production drill holes, and then you have RC drilling through that bench and down to the next bench, and you can see what's happening underneath. And this is actually from a mine. You can actually see that RC drill rig. You can just look at the screen when he's moving, when he's drilling, exactly like the other machines. It's a real-time system. And field exploration is the same. This is drilling in the field. You can see that they have drilled the profile with RC drilling. You can then, if you like, look at the profile from A to B and see a vertical picture, and you can see the rock properties from those drill holes. And this is, as I told you, online, or you can have the information immediately. You send the information from the rig. That can be after every drill hole or whatever you choose to do it. And example, if you go into details, you can go in 960, that whole number is. You go into that, you can see the overburden, first 6-7 meters, and then you come down to the rock level, and you can see the hardness variation of the rock. Here you go into a little bit harder rock, and then a softer rock, and you can see the geological structures. We do not normally like to put geological information because that need to be site specific. So we choose to just show the hardness, and then it's up to the mine to choose the geological colors or whatever they like to have. The fracture information is the same. You see small fractures in the beginning of the hole, and it's more and more solid, and that harder part is very solid rock. And you come out from it, you can see small fractures again, a bigger one down here. So this is how you can see the detailed information. And this can then be combined, of course, with a chip sampling. So if you then have a chip sampling system, you can have those points as well and see exactly where they are in the system. So I have now spoken about the surface mining. This is, of course, the same for all underground mines as well. It will just be another type of positioning system. Instead of GPS, we have other method to positioning the rigs. This is some examples from South Africa, for example, that we predict the content of the mineral percentage straight from percussion drilling. So you can see the grade immediately when they are drilling the percussion, the blast holes. And that's because, and it's normally is that way, that the content varies together with the hardness, in this case at least. So you can see actually the rock content immediately. And this is other examples from different type of tunneling and so on. And as I told you, the tunneling is a very, very good application for us, because when you drill around in a tunnel, you can immediately after blasting, you can verify all the structures that we had pointed out. And these we have been done for 25 years, approximately, hundreds of tunnels. So to summarize what I've been speaking about, is that this can be installed on all type of drill rigs, all models and brands, other machines and excavators, trucks, etc. Be customized to all type of mines. It is possible to start with a lighter system, GPS and management, and in a later stage, be completed to a full RockMa system with detailed rock properties. The price is, of course, very different to those two. RockMa is the market leading company for detailed rock property information for the drill rigs. RockMa has more than 25 years of experience from building rock mass analyzing systems. And as I told you, it's very easy to verify internally. Rock property information can be used for all waste boundaries, geotechnical information, blast properties, bit testing, etc. One of the mines that we have our system is, it's a very big testing mine today because of the system we have. They can test a lot of different bits by see what type of rock they are drilling. Drill quality has made big improvements. Production increase, as I showed you, the head turn time percentage has increased from 40 to 75%. We can increase safety. So this is the summary of what I told you. And with that, I will thank you very much. And for further information, you can contact Phil or Jared with these details. And other information is available on our homepage, of course. And with that, we are ready for taking questions.
Thank you very much, Kari. That was excellent, very interesting. I appreciate your time in the preparation of a lot of material. So can I just remind the attendees that if you'd like to ask a question, in the bottom right, there's a question and answer logo, and if you can just type your question in there. And in the meantime, I will commence with the first question. That comes from Barry McCready, who asks, regarding the drill hole quality compared to X and Y, you had 32 centimeters as the tolerance. What was the criteria used to determine this? And is it a function of the drill hole size or other criteria?
Yes, thank you for that question. This can be set to whatever. We actually, in some of these mines, they have changed the tolerance to 20 centimeter. Then they saw that they start to have 100% quality drilling all the time. They actually tried to decrease the distance to 20 centimeter. But we saw in the system that the production was actually not good because they started to need so much time to drill within 20 centimeters. So they actually start losing drill capacity while the leveling took longer time. So they decided to go back to the whole diameter tolerance, which was 32 centimeters. But this can be set to whatever. I know that there's other mines that have 0.5 meters tolerance, and that can be set to whatever in the system.
Thank you, Kari. Barry, I hope that addresses the question. If not, maybe you can just type a follow-up question, which we'll address when we come to it in sequence. Our next question is from Isan Musavi. And Kari asked, can coordination between explosive patterns, blast patterns, and short-term production scheduling be implemented simultaneously in live format, I presume he means?
That sounds absolutely possible. We haven't done it, but that sounds exactly what this is about. You can put in whatever information you have. If you have it in some type of digital format, it's absolutely possible to put in together. Yeah, thank you.
Thank you. We have two questions from Mark Button. The first is that fracture frequency is normally a very complex calculation involving analysis of core and borehole walls. How is this fracture frequency achieved in the RockMa system?
That is a very good question. It needs some time to explain it because we have two different steps in this. First of all, you need to decide when is it a fracture, because you have, especially in percussion drilling, you have some kind of what you call inhomogeneity in your drill process. So you need to have a certain fracture before you can notice that this is a fracture. And then you need to decide when is that fracture interesting. So you need to put that level in step one. When is the bottom level that you have? This is what you call a fracture. And then the next step is that you have the wideness of the fracture. And one fracture can be quite wide because it can continue of clay or whatever other minerals inside that fracture. So we calculate every 2 centimeter, for example, if you have 2 centimeter intervals, in one fracture can have 5 or 10 samples that indicates that fracture. And then we calculate them together, of course. So the fracture frequency is then the total amount of samples that have indicated the fracture that you have decided beforehand what is a fracture. And that is the way we calculate it.
Thank you, Kari. Mark's second question relates to the relationship between grade or ore body grade, in your example, manganese grade, and the hardness measured by the RockMa system. And his question is this work required for the correlation? Should it be carried out by the mine or by RockMa?
Normally, we do it together, because we can advise how to do it, and their expertise and their capacity to take a lot of samples, because it needs to be calibrated with a lot of reference material. You can't do it with just a few points. You need to gather the material that is available, and then you need to gather maybe some additional material to that. So it is something that we work together with the mine to sort out.
The next question is from Arturo Pugu, and he would like a little bit more information on this relationship with the grindability process.
Yeah, and that is also a very interesting and a good question, but requires a little more time. But very easily, I can explain that grindability is a property that is quite similar to hardness. Is the resistance of grinding the material, and it goes very close to that. And in many mines where you, for example, use flotation as the concentrating method, the grindability is a very important factor, because you need to calculate how much material you can pass through the concentrator. And if you have a material that is very difficult to grind, then the capacity of the concentrator will go down very much if you have a hard, very difficult rock to mill, so that it will impact on the actual ore grade. So in many cases, you can have ore grades that you calculate as ore, but to combine it with the grindability, it actually falls under the cutoff grade, and you can have marginal ore with a low grade that you look into the grindability, you can actually see that this is very easy to handle, and we can have a high production of it through the mill. So it actually goes up to become ore. So grindability is a very important factor, and we have done that very successfully in some cases to calculate the grindability. So you have that instantly. When you drill a block, you can also see the grindability information. Yeah, thank you.
Philip Gerish has a question regarding the dashboard. He says you showed one chart with many parameters for production and downtime. He's asking, how would that information be picked up? Is it operator input required, or is it generated automatically?
Much is generated automatically, but there is some input from the operator that we automatically can pick up, but a lot of it is automatically generated.
Thank you. Mike Woodward would like to know about other applications which you can exchange data with, other software applications other than the ones you mentioned.
We can actually send our data to all other databases, and I know that they are using it in different mines in different. If they have, I don't know the name of all these software package they have, but Leapfrog is one of them, and there's a lot of other similar type of softwares that they use for planning and graphical information. And so we can actually connect us to all of these system software packages that we have seen on the market. We have no problem to send our data in whatever format they like to have it. The common way for us is to put it all data into their bigger databases for acquired database or whatever they have, and then they can connect to those to pick up what data they like to have. But the answer is that we can connect to whatever software the customer is using. We haven't found any software that we can't connect to.
Thank you very much, Kari. Another question from Isan Musavi. Is the proposed method part of digital mining topics, or can it be developed?
Can you please explain it a little bit more?
Unfortunately, I can't.
Can you read it again?
Yes. I'll read it again. Is the proposed method part of digital mining topics, or can it be developed? Maybe, Isan, if you're still listening, I can ask you to maybe rephrase the question and we'll come back to that one.
I tried to answer it. I don't know if I understood it, but there's no development needed to applicate it to whatever mine you have. The system is quite fully developed. So it's really don't need further development. It only need adjustments to the mine specific requirements. I don't know if that answer anything, but maybe that was the question.
Thank you, Kari. Isan, if we didn't clarify things for you, please just type in another question and we'll attempt again. And then we have another one from Mark, thanking us for our answers on the fracture frequency and grade, and asking if you could please comment on the correlation of these factors as determined from the RockMa system and as determined by conventional methods.
That was a tough question, because conventional methods, I really haven't seen so much information about fracture frequency, for example. We have data, for example, RQD in core drilling, and we can compare to that, and we can see quite good correlation to RQD mapping. The problem with RQD is that is when you have it in the core, then you have a lot of influence and input into that core. It's matched in pieces when they take it out of the tube. It's matched in pieces when they put it into the boxes, and it different impact of different things. But in general, we can see a quite good correlation from RQD mapping and our fracture frequency, but we need to consider the difference. It's actually different type of information.
Thank you, Kari. Mark, I think also this is quite a complex area. So if you would like to just drop me a line by email to the email address shown, or send me a message on my cell phone, Kari and I can follow up with you in more detail. We still have a few more minutes. Oh, and another question has just popped up from Cesar Ulgadak. Which functionality of RockMa is the most praised one when it comes to daily use?
Yeah, this is also quite a tough question. Normally, the direct information is the real-time monitoring, that the mine can see exactly what is happening, that you can translate to money quite immediately. in my point of view, is the geological information is the most valuable in money over time. But the answer, I think, is that it's appeal to the production in a very short time, because they can see everything in real time. They can increase the obvious value of accurate drilling to blasting results. So I'm afraid that is what the customers see as the most important immediately. But over time, I'm absolutely positive. I think that's the rock properties.
Thank you, Kari. I don't have any more open questions, so if you would like to ask something, if I could ask you to type it straight away, and we'll just give it a few more seconds to see if anything pops up. If not, then I would like to thank you all very much for your attendance this morning, to thank Kari. Oh, just before I finish, Walter van Garth has got a question. Thank you for the presentation. After the pattern has been drilled, the drill pattern has been drilled, can you import bore track data for more accurate toe positions?
Yes, you can. There's several steps where you can do it. I know that in one mine, for example, they have, especially when it's raining and so a lot of mud coming into the hole, and they can measure the hole immediately after drilling, just a few minutes after. They can type in that drill depth into the system immediately, and you can have that video. And also, before they start charging the host, they go in and they can tape in different methods the depth to compare, and that can also be used if it is on the digital format. I don't know if that was the answer I'm looking for.
Thank you, Kari. So I think then that brings to an end the presentation. Kari, thank you very much indeed. Thank you to everyone who attended. If you do have further information or questions, you can contact me or Jared, or through the SIMM, they will forward messages on to us. And obviously we'll be happy to assist answering or providing further information. And with that, thank you very much once again, and enjoy the rest of your day.